We're a team of three, and I'm Luke Dettori, a mechatronics engineering student. My main role for our team project has been the scheduling, and accordingly, for the case project, I've been looking over the schedule management of NASA.
I'm Hunter Zhang, and I'm also a mechatronics student. My key role throughout this time frame has been the development of the video presentation and the research into the procurement management of our selected case study.
I'm Adam Benton, and that makes 3 out of 3 mechatronics students in Group C. I analysed NASA's quality management and the procedures they have in place to ensure quality. The 3 of us have worked together as a group before, and found we worked well together on similar projects in the past.
So your local trade is doing some work for you, and he says, you can have it fast, you can have it good, or you can have it cheap. Pick two. This is a very basic representation of the cost, quality, and schedule triangle, but is a crucial lesson that is imperative to any project management plan. Any project that attempts to achieve all 3 of these scenarios is not a project that it will be sustainable over the long term.
The Artemis program, sharing a naming convention with the earlier Apollo program, is a series of ongoing lunar missions with the goal to return humanity to the moon. Taken from the NASA website, with NASA's Artemis campaign, we are exploring the moon for scientific discovery, technology advancement, and to learn how to live and work on other worlds as we prepare for human missions to Mars. Alongside this, they have the goal to land the first woman and first person of color on the moon. The Artemis program can be traced back through the Constellation program and the Space Shuttle program, all the way back to NASA's founding. It is the latest in a long line of missions by the organization towards putting humans in space, with progressively larger program scopes. At a glance, the Artemis program is not progressing well, with project deadlines being pushed back repeatedly. However, Artemis 1 has successfully completed its task, with an unmanned launch vehicle performing an orbit of the moon, followed by an Earth landing in the Pacific Ocean, just off the coast of California.
The project of returning man to the moon was finally given the green light, and an overview was put to Congress in 2020. In 2019, Donald Trump, the president at the time, made several political statements about returning mankind to the moon and how great it would be for America. The public sentiment on the idea is largely positive, with a survey from the NORC Center for Public Affairs Research finding that 60% of the US population thought the space program's benefits justified its cost. Despite this, however, numerous other polls showed that most people are unaware of the Artemis program and are indifferent towards space research in general. As NASA is a US government agency, all its large-scale projects and any funding they receive from the government must be approved by Congress. This places accountability on NASA, but requires them to have proper proposals for any project to be funded. While this does give them a reliable backer, the US government has many organizations under it, and not all of them will receive the full extent of funding that they request. NASA's plan for Artemis, published in 2020 and referencing a project start in 2017, talks about the need to act fast and achieve a lunar landing by 2024 to help pave the way for Mars exploration. It states that 2024 is not arbitrary and was the most ambitious date possible, but over the course of the following years, the project met delay after delay, and currently the Artemis 3 mission has been delayed until 2026 so far. This presentation continues into an overview of the key successes and failures of the NASA Artemis campaign through the scope of 3 PMBOK areas: schedule management, quality management, and procurement management.
The quality management of NASA is one of their strongest PMBOK knowledge areas. As their projects involve budgets of many billions of dollars and the aims to launch humans into space, all their projects have massive risks and incredible technical requirements. As such, they have rigorous quality assurance procedures and an uncompromising approach to quality. There are a wide variety of challenges associated with space, most of which are brought about by a lack of atmosphere, such as exposure to extreme temperatures and radiation. This makes material selection extremely important, and any minor quality issues that are negligible on Earth may cause catastrophic failure in space, putting people's lives and billions of dollars at risk. Due to the severity of these risks, NASA has applied its extensive quality management procedures to the Artemis program. In PMBOK, quality management is broken up into three key areas: quality planning, quality assurance, and quality control. These are, in simplest terms, considering quality before, during, and after the fact. The Office of Standards and Mission Assurance is the organization under NASA responsible for the organization and updating of NASA standards, and their main quality planning department. They have a massive range of standards, with procedures such as lifting heavy objects, handling explosive materials, and assuring quality and reliability of electrical components. By having standards and policies for such activities, NASA aims to mitigate or reduce any potential risks of low-quality work and the harm that they can cause. Their standards and policies are under a revolving review schedule to guarantee that they stay relevant with changes to the organization. Currently, the OSMA website lists 10 different policies which are undergoing review, and one brand new policy added just this year. All NASA projects must comply with these standards, Artemis included, which massively reduces the risk of low-quality work. Quality assurance is the process during manufacture and assembly to maintain the quality of work done and prevent technical issues. This is done through implementation and adherence to standards. NASA provides staff with courses on safety and quality procedures, such as controlling particulate contaminants, recognition of chemical damage, and how to complete procedures to minimize mistakes. These courses and the existence of dedicated quality staff help maintain a workplace that prevents any low-quality work from making it into a finished product and helps prevent failed launches. Considering that NASA is outsourcing portions of the Artemis program to other companies, such as SpaceX and Lockheed Martin, there is increased difficulty in maintaining quality, as different organizations have different procedures and standards. For example, there is potential that something designed by SpaceX does not meet the NASA standard. To prevent such an issue, NASA has standards on product integration, which is the process of checking if externally sourced parts fit together with the project. This quality checking step is applied to all outsourced work before it is integrated. An excerpt on this procedure, taken from the NASA website, reads, "This validation can be conducted by the receiving organization or by the providing organization, if fully documented or witnessed by the receiving representative. This helps maintain that outsourced work is not a cause of concern when it comes to product quality, and allows for the outsourcing of major components of the Artemis program." NASA also has an extensive quality control department, which is tasked with inspecting and approving finished products. Their website lists in-house materials testing, weld testing, failure analysis, non-destructive testing, and calibration services, which are used to guarantee that work done is up to standard. When you consider that NASA equipment is designed for launching into space and sustained space operation, it is quite obvious why they are so rigorous. Any issues with quality, even as small as a single bolt being loose or a weld being cracked, can cause a loss of ingress protection, causing a spacecraft to leak its air supply or other valuable resources. NASA Administrator Bill Nelson stated in early 2024 when asked about Artemis delays, "In the process of all this, as we remind everybody at every turn, safety is our top priority. And when it comes to high-complexity, large-scale technology, safety requires high-quality work. When considering the project management triangle, a balance must be found between quality, cost, and time. However, in the context of the Artemis program, quality is of utmost importance, as the potential effects of poor quality are severe. Judging from the schedule changes and the success of the Artemis 1 launch, NASA has upheld the quality of their work."
PMI states that time management can be broken down into 4 key processes: planning, estimating, scheduling, and controlling. Essentially, to plan out all project activities, estimate the time to complete each task, schedule tasks with a realistic order considering sequencing and resourcing constraints, and then to control by recognizing what has happened and take action to ensure future objectives are met. One major event in the formation of the NASA Artemis schedule was pressure from the White House to change the original 2019 plan of a 2028 human lunar landing to 2024. NASA should have used their authority as an expert in the space industry to push for a more reasonable timeframe, rather than cutting their original schedule in half for it only to be expectedly delayed. A major source of delays has been their contracted work. The human landing systems were put out as contractual work, with NASA announcing this to industry in 2019. This work was eventually contracted to SpaceX. A 2023 report written by the GAO, or Government Accountability Office, shows that in 2021, NASA announced it would be able to launch Artemis 3 no earlier than 2025 due to a 7-month delay with the HLS. As of January 2024, NASA has now targeted September 2026 for their Artemis 3 launch, but will this be achievable? The 2023 report estimated that there would likely be further delays until early 2027, considering the past major NASA projects. The proposed date by NASA is 13 months faster than projects in the past 13 years. The majority weren't human spaceflight projects. Milestones for the project agree with there being larger delays, as milestones for the HLS are further behind other NASA projects when considering their schedule. Two key milestones in NASA's projects are the Preliminary Design Review and Key Decision Point C. On average, these reviews have been done after about 1/3 of their total scheduled time for the given project. In contrast, the HLS has used a little over half their schedule to complete these reviews when considering their scheduled project end of 2025. This also pointed to a need for more delays, and was information NASA should have been considering earlier in the project. SpaceX has also delayed several key events, compressing the current schedule further and presenting more risk to timely completion of the project. Time will tell if the current NASA estimate will also be delayed further and become more in line with the report. One component that might be fueling these failures is a lack of mission-level schedule guidance. NASA's current schedule management guidance sources are only program level, whereas Artemis consists of multiple programs linked together under a mission. The GAO had pointed this out in a 2022 report, to which NASA had responded saying this would be implemented by August 2023. This still seems to be incomplete according to the GAO. This same report also suggests that NASA do a scheduled risk assessment of the Artemis 2 after the Artemis 1 launched, to incorporate scheduled updates and identify new risks. NASA agreed and planned to do this in late fall 2023, but according to the GAO, this was also not completed. This demonstrates that even with external analysis of their project management by an accountability office, they still haven't regained control of the project as well as they could have. Amongst all the delays, it can be difficult to see success in NASA's approach to schedule management. To really appreciate their capability, you need to consider the scale of the project that they are managing and how wrong it could have gone. The GAO identifies that NASA had created a schedule that was fully in line with 3 of their 4 applicable best scheduling practices, and partly with the other. These 3 fully met practices were that the sequence of the work is logical, that the duration of activities is reasonable and split in a way that can provide detail to the reader, and that the identified critical path is actually valid. The partially followed principle was about horizontal and vertical traceability, with Artemis being horizontally traceable, but there being issues with its vertical traceability, specifically with the Orion Integrated Master Schedule. Going back to the PMBOK, this demonstrates a good understanding of estimation and scheduling for the most part, and the types of delays being observed don't point fault at their work breakdown structure. Considering the scale of project, large number of tasks, and interrelated components over the project, this demonstrates the expertise NASA has in managing large-scale projects, even if they still have room for improvement.
According to the PMBOK principles, Procurement management includes all of the procedures required to buy or get products, services, or results that are required from sources other than the project team. It involves conducting procurements in a way that manages risk, ensures quality, and achieves the desired outcomes of the project. This management area oversees the creation and execution of agreements such as contracts, purchase orders, memoranda of agreements, or internal service level agreements with companies at all levels of the supply chain. Project procurement management processes include three main areas. The first is planned procurement management, the process of documenting project procurement decisions, specifying the approach, and identifying potential sellers. The second is contact procurement, the process of obtaining seller responses, selecting a seller, and awarding a contract. And lastly, control procurement, the process of managing procurement relationships, monitoring contract performance, making changes and corrections as appropriate, and closing out contacts. Whilst these procurement procedures are depicted as individual processes, in reality they can be quite complex and often overlap with other PMBOK knowledge areas. Now, due to the scale, complexity, and intensive integration of advanced technologies, NASA's Artemis program required a steady and reliable procurement management plan to ensure its success in such an ambitious time and cost budget. Unfortunately, this did not happen. Failures and oversights in the initial planning cycle resulted in plaguing challenges in resource acquisition throughout the ongoing project that have impacted the overall program so far. This is further exacerbated by the large number of external suppliers for the components and expertise for this project. These challenges highlight the areas of improvement, adjustment, and overhaul that are needed for the project to not experience any further delays and failures in this PMBOK area. A major challenge in the Artemis program's procurement management was its utilisation of single-source suppliers for much of its specific components and technologies. Systems that included proprietary technologies or specialised expertise resulted in being extremely problematic as they greatly reduced the number of potential suppliers. When these suppliers faced problems that were out of NASA's control, such as production issues, regulatory challenges, or financial instability, which all occurred at some point, the program was subjected to significant project delays as it had no quick alternatives or backup plans. One such aspect that was affected by the use of an individual supplier was in the procurement of valves and electrical, electronic, and electromagnetic parts. These components were crucial for the Space Launch System and Orion spacecraft. With the initial supplier having a lack of parts available and long lead times for their manufacturing delivery, the overall project schedule was subsequently delayed. Delays in these tasks then further cascaded to those that required their completion, and so on and so forth. Overall, this situation depicts a failure in Area 1 of procurement management and highlights that having multiple sources for critical components is extremely important to ensure that supply dependency is not a key factor in the project's plan. NASA's procurement for the Artemis program also became challenging due to failures in scope creep and not remaining on the pathways determined in the initial plans and objectives. Throughout the project's lifetime, flowing and evolving technical requirements and changes in mission objectives led to contract changes, often requiring renegotiations with suppliers that then further delayed the acquisition process and led to cost increases. One such example of this failure came in changes to the human landing system design to increase the safety which is expected. Now, this involved the re-evaluation of contracts with already purchased and delivered components. This then flowed into further time and financial expenditure in order to meet the new specifications. Now, without a strong change management plan for procurement of these resources, the Artemis program underwent extended deadlines and budgeting increases. This failure is directly related to a lack of attention to Area 3 of procurement management, resulting in excessive changes without monitoring the active scenario. This showcases that a project that is expected to adjust to changes in procurement due to scope changes, such that it does not affect the surrounding system, requires an adaptable yet resilient plan to change management. In an attempt to resolve these challenges, the NASA Artemis management team employed several strategies that each came with their own benefits, but also their inherent limitations. The first attempt was to diversify their supplier base to deal with dependency risks. This approach aimed to reduce the bottlenecks of the project, but resulted in integration nightmares between all supplied components, thus requiring stringent oversights to ensure the previously discussed quality control was upheld. Improved risk management was also implemented to identify and mitigate procurement risks. However, this required accurate and timely information due to the inherent complexities of the Artemis program, and as such, not all risks could be effectively mitigated. Another approach was implementing stronger performance monitoring systems, such as setting up the Insight Central and Prime E databases to ensure contracts were achieved and upheld. And while this aided with the previous approach in preventing further issues, this also led to increased administration costs and risked harming supplier relations. From these failures and challenges in the procurement management and the attempted resolutions approached, several key lessons can be learnt. First, there is a very clear need for improved risk management practices within procurement processes from the very beginning, specifically around the identification and mitigation of supply chain vulnerabilities. Secondly, the Artemis program highlights the importance of developing resilient contingency plans that include varying suppliers and buffer stocks for critical components. Such measures would ensure that the program can maintain its schedule even when primary suppliers face delays. Understanding the mechanisms of the replacement components also further reduces the risks from any integration issues that may arise down the track. Finally, a better integration between the procurement management and other PMBOK areas such as scope, schedule and communications management should be implemented to ensure that the procurement activities align with the initial project requirements without excessive scope creep to ensure that project milestones are upheld rather than hindered.
In our analysis, we found that overall, NASA has an incredible yet fallible structure in place for project management. Their underlying processes around quality and schedule management have been refined through many high-stakes projects in the past, and we feel we learned a great deal about how to set up an organization for massive scale projects from analyzing their work. The major issues that arose with the Artemis program were caused by rushing the initial stages of the planning process. With the US government pushing for a faster schedule, the project was condensed into an unreasonable timeframe. The project was rushed into action without finalizing a complete project plan and by introducing a new and vast methodology for procurement. This, as you might expect, led to issues. Alongside a rushed project start, as explained in an internal audit by NASA, NASA's 3 initial Artemis missions, designed to culminate in a crewed lunar landing, face varying degrees of technical difficulties and delays, heightened by the COVID-19 pandemic and weather events that will push launch schedules from months to years past the agency's current goals. These events are not preventable, but should have been considered in the initial risk assessment and had control measures in place to minimize impact. By the guidelines of PMBOK, the Artemis program can be considered a failure of a project. It has failed to meet its stakeholders' expectations in terms of cost and time, and has failed to make corrections when provided with external feedback. The only thing holding this project together is the backing and ability of the organization, not the way the project has been managed.
Key takeaways for NASA from this mission are to take more time to start and ensure a solid plan is formulated before major work is started. As part of this, they should develop guidelines for creating mission-level plans by reviewing previous mission-level work, such as the Apollo missions. This will help with future missions of this scale and prevent the same mistakes from happening again. If they plan to continue contracting large-scale jobs such as the HLS, they should lean into their strengths of quality management and apply the same rigor and focus into making stronger communication guidelines, with better focus on expectation and support. Part of this would also include more clarity at the start of the contract to ensure that they don't need to change critical components of the resulting designs later into the project lifetime. NASA should also be more wary of implementing large changes into their procedures, such as acquisitions, when undergoing critical large-scale projects such as Artemis to help reduce complexity. There also needs to be better communication streams between the NASA and the US government for future projects so that they can maintain reasonable timeframes in their projects. and NASA should have a larger voice considering their subject expertise. It is rocket science, after all. Regardless, NASA is still an organization that can often demonstrate how to manage projects of incredibly large scale effectively, and the study of one of their projects has provided valuable information.